Still getting somewhat situated here. Let's get the microphone a little bit closer. Oh, the music's way too loud. Try and get these cables out of the way. There. How is everyone doing tonight? I thought I wasn't going to make it, but I made it anyway. Wait, now there's no music? Oh, the song ended. Let's see, is anyone here? 31 people are here. Nice! Are you all here to see me butcher up this power supply? Let's put this over here, I don't know. Let's see if the top cam is working. It's not, is it? Rob van Gils thinks we're going to have fire. We'll see, we'll see. Why is it so dark? Why are we at... Okay, hold on. See, I didn't prepare this part. No. There. That should do it. Okay. Yes, good. So while we're in the pre-show, I can chat with you guys, and we're going to work on this thing. Okay, so dark on dark is way too dark. Who would have imagined? 5,000? Oh, wait, I see what's going on. Somehow I messed up the settings of my camera. There! That should be, although it's dark on dark, it should be visible, right? You're in time, Jessa. No worries. Let's start from the beginning. Because Ernesto was here at like 5:44, and he was like, yes, I was just looking at mine in the garage last night, thinking of doing the same thing to gain some space on my workbench. Exactly. This giant thing is here, and if I can lose most of the bulk beneath the desk, that would be nice. And it's actually not because of the bulk, but more because of the noise for me. No music yet. Well, we fixed that. Second here, says Nigel Young. Gonna be good tonight. Von Tolkien is here, and Fat Daddy G8Z. The Omni Everything Power Supply. Okay. Rob van Gils is here. Nice. Are we there yet? Asks Johnny. Well, I'm here. Are you here? Hello from Laytown. Okay. More smoke, please. We'll see. We'll see. Do an LTT and put the power supply in the other end of your house. Well, that's what we're trying to design with Power Diff, but then the right way. Any update on the new big power boards to deliver power over Cat 6? That's what I was just talking about. No, not yet. I'm still stuck in development. Don't know when that's going to be done. Anyway, while we're in the pre-show, I have something we need during the show, or during the live stream. So I need to... well, it's 3D printed, as you can see. You might recognize the shape. Because I was like, if I'm going to take out the front plate of this power supply and then put the whole case somewhere else, what am I going to put in it? And then I found a 3D model of the front. I was like, I'll just 3D print the front. But we need to take these little trees off because it needs lots of support. These are coming off pretty nicely. It's not hard at all. I was already prepared to grab my tool and everything. Okay, these ones stuck. Here, one of the trees failed to print, I guess, but the 3D printer was like, hold on, I'll just bridge that, no problem. This was printed using some PLA Meta I got during the sale on AliExpress. I might make a video about that at some point, or in a Quinn box, not sure yet. The second IP address? How do you mean the second IP address there, Fat Daddy? If you activate Ethernet, you have to disable Wi-Fi. Ladytown, also known as Lady Stop. Aw. Let me find a little tool here. Got to remove these supports. There. Lost the signal? No. Our signal's looking great tonight. Okay, let's try and get these off. Oh, pretty easy. Okay, here it's kind of borked. Or not. Doesn't have to be perfect. This side's going to go inside the chassis anyway. You got your support settings down. Well, that's then thanks to Orca Slicer and Bamboo Labs. The sports go off way too easy. I have an X1C carbon, and this was printed using Yayo, but that's a Sunlu sub-brand, PLA Meta at 210 degrees. It looks good. There's a little imperfection here, but nobody cares. Yeah, and it just came off like this. I added a 220 before, but then I got some stringing. But this is a 210, and that's looking fine. Yeah, Quinnergy's still on hold, sorry. For railroad modification, no, these are just support trees. Now there is some support here underneath the dial. But I don't think I'll be able to get that out, and this dial it's just fake. This whole thing is fake. So I don't really care. Yeah, but I switched from my heavily modified Ender 3 to an X1C carbon, and it's been night and day. Now I've just been printing instead of messing with my printer. I mean, I know that's what they say, but it's true. It's really true. And even with, like, okay, let's buy the cheapest PLA Plus and PLA Meta you can find on AliExpress and run it through there, it works beautifully. I didn't do anything special. It just comes out like that. So yeah, X1 carbon with 1 AMS, it's expensive. I'll say that. But I mean, if you want to get started with 3D printing and you don't mind tinkering with it, that might not be the printer to get. But I use it to make prototypes for casings and for PCBs even, to fit in casings and all kinds of prototype stuff. And then it's great to just hit print and not have to worry about it. And have it done in like an hour. Well, this thing took 2 hours, 2.5, something like that. And it's not... I think I used 8% infill and 2 or 3 walls. But yeah, that's plenty for what we're doing. Now, I do wonder about these things. Because these are supposedly clips to hold it into the housing. Well, sure. I mean, the 3D model had those, so it printed them. But these are not movable at all. So I really doubt that's going to work. But we'll just jam it in there, and you will keep your Prusa Mark III's Bear Edition. Okay. Well, Prusa's nice too. So, you know. Yeah, okay. Well, this was just for fun. It's a one-time crack. Yeah. It'll have to break the 7 or 8% infill I did. We'll see. We'll hammer it in there. That's fine. I was actually thinking of using a drill, and because there's going to be cables that have to come out of here, using a drill and drilling it through here, and then routing the cable through there. But I have to see if 10 gauge cable, which we want to use, if it'll actually fit through there. No. Aw. So sad. Nope. 10 gauge won't fit. Okay. Barely. Maybe. No. Nope. Okay. That's okay. So we're going to be doing some drilling into the 3D print. And yeah. Anyway, this is supposed to be the pre-show. What are you guys drinking? I have Fanta Exotic. And sorry it's still overexposed. It'll become better once the sun goes down. Actually, that's going to be a while, isn't it? Let's lower the ISO. There. Now it's not overexposed. Can we still see this? Yeah, somewhat. Okay. Anyway, do we need to make it an ultra? I guess we do, huh? Aldi lemon iced tea. That's good stuff. But it has sugar, and I'll die. Ultra, no, Ultera. Yes, it's a new version. It's called Ultera. Let's see. I was just on vacation, and so they spoke a different language. I went to France, so they spoke French. And I don't know what ultra in French is, but now it's Ultera. It's like it's from the earth. It's a very small ultra today. But it will make the drink taste better. Because now it is Fanta Zero Sugar Exotic Taste Ultera. Nobody has the Fanta Zero Sugar Exotic Taste Ultera edition. Anyway. Lunchtime whistle can only be ignored so long. Later, Fat Daddy. And I'll tell you what. If we get this to work, in theory we should, but it's like I prepared everything and then I got all the wrong stuff. So it's going to be the Ultra Jank edition today, because we're going to make the wrong stuff work. That's the idea. So, if it does, it'll power the new secret I have, and we'll see at the end of the show. We're finally having a bit more normal weather over here. It's been 30 degrees. It's scorching hot. I could only spend like 1 or 2 hours in the garage, and then I'd have to go into the house to cool off. Today was good. Yeah, today was a little bit cooler. That's nice. I like it. I like that it's summer. It's just there's such a thing as too much summery. Mazza banana drink. Never heard of that. We had a day of rain and thunder. Well, Thor lives near where you live, doesn't he, Johnny? Only managed to get like 3 hours of sleep because of heat yesterday. Yeah, when I designed this house and we built it, there was an air conditioning in the bedroom. I was like, nope, not gonna sleep on the attic without an air conditioning. It's not gonna happen. I am now X years old, so I'm no in my mature life, so I can now have an air conditioning. Oh, hey, Neil. From Greece on a boat. You're on the 4G, 5G. You'd rather have 2 degrees instead of 30. No, I don't like the winter. I get all kinds of rash and stuff. I do like it when it snows. Then the winter is nice. I like a comfortable between 20 and 27 degrees, something like that. And we had luck because we went 8 days to France, and we had good weather. So. Okay, I think I'm just gonna go get started, because satellite. Ooh, you got Starlinked? So, anyway, let's get started for today. What we're gonna do today, Disney Cruise. What? What is a Disney Cruise? I went to Euro Disney for the first time in my life. It was awesome. We did all the roller coasters and stuff like that. What the hell is a Disney Cruise? Do you go to all the Disneys? Where's Kitty, though? I think Kitty's in the living room. I don't know. Maybe he'll come say hi. Mickey Mouse. You're just saying words now. Anyway. Okay, let me dismantle my my giant power unit here. Okay. Hold on. Okay. Dismantle the studio while I'm using it. The garage studio. Oh no. It's all coming down. No, it's Disney themed on the boat. But it's a lot of Greek islands here. Okay, so you get a bit of Greece and Disney. Huh. Oh, interesting. Okay, I think I made it work. I think. So, anyway, here is my RD, let's see what it says, 6012. And we built this one on stream. We later built another one, a 6018 or 24. I think it was a 24 actually. I think I wrote 18, but I think I got a 24. Anyway, this is a RD6012, and it's a benchtop power supply that lives on my bench. And all that so far is great. The problem is, oh, no, that's not a problem. The problem is that it's this large. Because I like it a lot. I use it daily when I'm testing and building stuff and you name it. So I like it. But it's this big. And that is a problem. So there's a giant power supply in there. But the power supply and the front unit are basically linked together with cables. And I was like, so what if I 3D printed a little box that I just downloaded somewhere online, and well, okay, let me get the XT60 connector out there. 3D printed this box here with some leftover old. This filament was like 4 or 5 years old. I threw it on the X1 carbon. It printed beautifully. It's amazing. And this one is also really old, but here you can see some weird lines. But yeah, I don't care. Anyway. What if we can put the front unit in here and then have some cables coming out of the back going into here, right? And I was like, okay, but then this is open. That's not nice. So I printed its cousin. I was looking online and I was able to find basically the model for this front plate. So I just printed it. It doesn't work. It doesn't do anything. I was like, this should fit because it's the same thing, right? Is it? Will it fit? Oh. I think so. Yeah, it looks pretty the same. In theory, that fits. So that's what we're going to do today. We're going to take this out, dismantle it, build it into here, so that this can live on my desk and take up a lot less space. And then we should be able to put some XT60 connector here on the back. Of course, I ordered the wrong thing, because this has a nice cutout for a male XT60. But of course, what did I order? I ordered female XT60s. So this won't actually fit. We can't use this. So we can't screw it in there. So that's my bad. Scale times 0.02. We'll see. But I did notice that if I take the normal XT60 plugs, which I have enough of, I can just jam it in there. Like somewhat like this. There. Oh, well, it should go like something like that. And then if you make a cable with an XT60 on there, I'll have to glue this in somehow, but anyway, this should mate with this. So then it's fully modular, and you can put this anywhere on your desk and disconnect the cable if you don't need it, and yeah. So what we're going to do today is we're first going to figure out the 2-degree preference. We're first going to figure out how many cables we need. I think there's only one positive and negative, but there might be two. And then if there's two, well, then we need more holes. And then the solution for that is going to be a power tool. And I'll just make more hole. Well, I have no idea if that's going to work or not. We'll see. Then we'll glue those connectors in there. No, we have to first make the cables, then we'll glue the connectors in there, and then we'll route it to this guy, and we'll just route it through, we'll drill some holes through this front plate, maybe in the window, just, you know, in the LCD window, just to make it funny. And then we'll stick that in here. And in theory, then we'll have a disconnectable power supply solution with only this thing on the desk. I have no clue. This is going to be jank AF because I got all the wrong stuff. But yeah, that's what's going to happen. These are XT60 connectors. It also says it on there. XT60. And they are soldered connectors, so you can put some solder in here and then the wire, etc. And then heat shrink it. And they are polarity matched. So if you get two of the different sides, nope. Yep. So one side is round. Hold on, let me zoom in more. One side is rounded, as you can see here, and the other is flat, and the same goes over here, and there's a notch too. So these mate together pretty securely. There. And then you have a connection which will do 30 amp continuous, I believe, and 60 amp max. Oh, Dave Odessa's here. Sounds like a great idea in theory. Exactly. Open the power supply. I want to see inside. Yeah, well, we're going to open this chassis first. Oh. We actually built that thing many years ago on the stream. I'm not going to say it's one of the first streams. I don't think so, but could someone look it up what stream number it was that we built the RD6012? Because we also built another one, either an 18 or a 24. I don't remember. Was it an 18 or a 24? Hey, MSX is here. Good evening. Could someone look it up? I'm really interested to know. But will he fuse it, just to be sure? Well, it's fused already on the front panel, at least. And we're just going to use insanely thick cables. It's in the garage. It's connected to the Quinled battery, the one I built, because I left it alone for so long that the BMS in the screen actually drained it down to like a few volts. So I had to recharge it back up to like 56 volts. And that it did beautifully with like lots of amps. So, okay, here we go. I don't need this for right now. Oh, right. We glued the temperature sensor. We captain taped the temperature sensor on here. Number 8. Was it stream number 8? Yeah, I told you it was one of the first ones. So this is the official power supply that goes in here. An S860. The termination is... Oh, Neil is... Okay. Yeah, and the later one we built with a different type of power supply. So, we're not going to be able to take this temperature sensor along. So we're going to remove that from the power supply. I'm almost first, says Slicer. I don't know, man. You're kind of behind then. So let's get this off. I later learned that you should have this one externally anyway, so... No. This is a brand on AliExpress at least, but it's probably an official brand. I actually thought about maybe replacing it with a Meanwell and then a silent one, but that might be another upgrade I can do later. For now, we're just going to use this one, because it's been working fine. It just makes a racket. It makes a bad... Well, not bad noise. It's just noise. And I don't like noise on my desk. But it's an NVVV. And it's 800 watts, 60 volts. So it can output 60 volts at 13.3 amps. And I believe we slightly upped the voltage a little bit to like 65. I'm not sure anymore. Actually, we should check that, because we kind of need the same voltage after the cable has been connected. So let's check what voltage is coming in right now. Yeah. So let's see. Riden. Okay, it's set to 70 volts. So although it's a 60 volt power supply, you can always adjust the knob a little bit. And it's set to 69.58. 69.57. 69.56. It's still going down. Anyway, we're going to say 69.5, right? Okay, that's good to know. So once the cabling, the longer cabling is in there, we should still see about that voltage. October 24th, 2020. Well, that's how long I've been using this thing. Like, well, at least once a week, but often daily. It's been great. It's been good. So, yeah. So, we're not going to remove the power supply. We're only going to remove this thing. And as I see here... Oh, interesting. So, the connections over here... The connections over here are 2 screw terminals, 2 for negative, 2 for positive. Okay. And currently they are connected with... I can't really see right now. I'll check that in a minute. But not really thick cables at all, because, well, of course it's a very high voltage, so it wouldn't need very thick cables. But I think we're going to replace that with one cable, which then has forks over here, which will go into both terminals. And there's only going to be about 10 amps or so. Yeah, this Chinese guy, his logo looked like Meanwell. Yeah. But this was the official recommended power supply. So yeah, I think we're going to go to one cable. And I don't think that's going to be a problem on the power supply side. Normally, if you're going to do a lot of amps, you do want to use multiple of these terminals. But since we're doing 70 volts, even if we do 5 volt 10 amp out, that only means like 1 or 2 amps have to travel over this cable. Smoking and melting. How long will the extension cable be? I don't know yet. I haven't figured that out yet. I think like a meter, maybe 1.5. Something like that. Because I kind of wanted to have it go under my desk over there. It tells you nothing. Over there. Or somewhere over here. and then have the cable come up and have the little box here with the control unit on the disk. So let's first see if we can get the control unit out. I think we're just going to disconnect the cables. Oh, is this pluggable? Oh, it's a pluggable connector. Okay. Well, then I'm really sure they're not using a lot of amps, because those things can't handle a lot of amps. So now there's these clips here, and I think if I jam my screwdriver in here, maybe I need two. Oh, no, there it goes. Wait. Wait for what? Yeah, it's unplugged from the wall, don't worry. Otherwise, this is the DC side anyway, but, you know, maybe with 70 volts. Could still hurt, I guess. Yeah, no, look. And I turned the power switch off too. Okay, so now we have this case. Good. And we have the actual control unit. And somebody asked about a fuse. There is a fuse here, as you can see. It's a 20 amp 1808 fuse. And keep that fuse in mind. You might see more of it later in the stream. Who knows? Okay. Anyway, this board looks pretty nice. It's been working great. Max input 70 volts. Okay, that's why we put it on 69.5 probably. Oh, there's another fuse here. It's another 20 amp fuse. Come on. Yeah, there's another 20 amp fuse there. Okay. There we have a relay. Little fan. Let's hope this fan isn't the one making all the racket, but I believe it's the power supply. I'm pretty sure about that. Anyway, that is step one. No, I'm pretty sure it's the fan of the power supply that's making the noise. Yeah, the 12F is because I got the wireless version. Never used it. Okay, let's first see if this will actually fit in here. Because I don't know. Now, I shouldn't pop it in, because then we'll never be able to get it out. Oh, wait, the designer actually thought of that. Because these screw holes, they line up with these tabs. So you can actually still press the tabs while it's in there. Uh-oh. Oh, that's going to be a tight fit. But, oh. It just snapped in. I wasn't going to push it in. It just went. Well, okay. It fits. Look, you can see the components in there. Okay. Yeah, that's a good fit. That's a perfect fit. Yep. And there's some ventilation holes here. Now you will never get it out. Thanks, Johnny. No, I think that's why these holes are there. There. Oh, look at that. Oh. There we go. I don't know who designed this case. The link is in the video description. But he did a good job. Perfect fit. Nice. And that for using some old filament I had lying around. Okay. So then what I want to do is I want to go from the control unit and work backwards. So we're going to take this pluggable unit. Did you design the case, Johnny? Okay. So ground goes here. Yeah. Okay, so we don't need this for right now. And I did prepare this, I think, well, a little bit. Let's get my box of large crimpies. Who designed 3D? Check in the video description. There should be a link to that case. So I think we need not 3.5. This has no label. That's not helpful. Okay, I think we need 5.5-5. Let's see if that works. Yes! Oh. Let's see if I also have a black 5.5-. Oh, those are rings. No, I don't need rings. Is it these? Maybe. (5.5-5). Okay. So this should work. There. Okay. Nice. Right, so we can, this is also what's possible on the Dig Octa Power 7 and the Dig Quad. You basically take two terminals, and if you want to run a really thick cable, you use a fork, and then you just screw down on the fork. And these go in far enough there that you can screw them down tightly, and they'll make a good connection. Because these are 5.5, let me show you, RV 5.5-5. That means we can use 5.5 millimeter square maximum cable, and it has a 5 millimeter spacing for the forks. And I believe we'll have to look at the calculator. Let's see what the calculator says. Are these not separated rails on the power supply? Normally they are. But because we're not drawing a huge amount of amps, that won't matter. It's just to double up on cabling. I do that with the Dig Quad and Dig Octa too. You can use 2 or 3 input cables from a single power supply. But that's because of the amps, not because of anything else. So if you're not drawing a lot of amps, that's going to be fine. So let's convert 5.5 millimeter square to AWG. That is 10 AWG. And look what cable I came prepared with. Maybe we look at the black one. This is 10 gauge. So we should be able to make 10 gauge from this guy, right, to the back over here. We then have to glue this XT60 in place because I've got the wrong one, so I can't use the screw holes. And then we run another 10 gauge from over here all the way to the power supply unit. And then on this one, I think I'm just going to drill 2 holes and feed the cable in there, and then connect it with some forks again. If you would be running 30, 40, 50 amps, that would be the wrong thing to do. You need to use multiple of those terminals. But if you're only running like 10 amps, one terminal can supply that just fine, right? So that's no problem. So here we're just going to drill it through because I don't know another way to do that. Does anybody know a better way how to do that? Maybe we can somehow put an XT60 in here. I guess I should have designed something for that. I don't know. I'm not good at 3D design. So yeah. It's not happening. Not today. Maybe we can upgrade later. Okay. So I guess we'll crimp this side first. MagSafe? What? Why would you use that? So let's see what length cable. We don't really need much, do we? These terminals are up here. So they're up here, and they need to go... Oh, wait. They're up here, and they need to go here. So they really don't need much cable. Okay. Yeah, I wanted to use the fake connectors, these ones. But the 10 gauge, it doesn't fit. You can't get it into the connector, so that kind of sucks. Maybe we can drill out the connector. We'll try. I don't know. Okay, so I really don't need a lot of cable. I think something like... Oh, something like just this is already enough. Because then, let's see if this is here, you can still remove this part fine. Yeah, let's do that. Okay. This tool isn't really ideal for cutting this cable, but it's okay. Yeah, but I think even with this length, if it's sticking there, it sticks out that much. So that's fine. And this is a removable screw terminal anyway. Let's see, we're using forks. Oh, we already have the forks here. So let's strip some cable, and since we're using forks, we don't need a lot of exposed copper. Something like this should be fine. And yes, I'm going to twist it together, and you shouldn't do that, blah, blah, blah. I know. So let's get the crimper out, and we need to use the largest spacing for that. And I always make them in there and do one tick. No, okay, not one tick today. And you want to feed it in there until you kind of see the copper poking out a little bit, and then you crimp it on the metal part. So the crimp goes here, which is the metal part, and it'll also automatically crimp the plastic a little bit. And in theory, yeah, that's going nowhere. Now, I get these from AliExpress, and you can get them in all kinds of colors. Normally, these would be yellow, I guess. Okay, copper is sticking out just a little bit. Yeah, that got nice and flattened. Perfect. Good. Crimping done. So now, if I remember correctly, it goes in like this. And this should be negative. Directional. Well, the front and the back aren't the same, but I believe that's on all crimpers. So let's see if this is a good connection. Yeah, I'd say so. That is definitely in there and making a fine connection, I'd say. Yeah, and I mean, using one cable instead of two, yeah, that's going to be fine. Left and right side, not the whole sizes. Oh, yeah, it has a different teeth. So you need to put it in the right side. Okay, perfect. That fits just perfectly fine. So as you can see here, the 3 little dots, those should be on the metal part, and then this side should be on the cable part. Here's the 3 little dots again. So yeah, the crimper has a bit in there that, you know, has sides. Okay, good. So that's gonna work. So now comes the harder part. Is there a convention for XT60 connectors? What is positive and what is negative? Because I don't know. XT60 positive, negative. Okay, power should be on the round side, or positive, and ground should be on the rectangular side. Oh, wait. There is actually symbols on here, but they are exactly reversed. Here is a little symbol of a plus sign, but this is the flat side. And then over here is a symbol of a negative sign, but that's the curved side. And what I'm seeing online is exactly reversed. Put in the other connector while soldering, it'll melt otherwise. Okay. So the first one I'm looking at is just wrong. Because ground should be on the round, no, I don't know. Yeah, ground should be on the round side, like it's on the connector. I'm just going to follow what's on these connectors, because that makes most sense to me. Okay, so I need to solder to this guy. Okay. Now I haven't soldered XT60 in many years. Let's see, I need to use the long side, right? Yeah. Okay. Am I gonna fit 10 gauge in there? I hope so. Let's do something else here. So like this should be correct. Let me get my soldering iron. My wire is all tangled up. Oh, come on. Need to untangle this for just a second. So much stuff going on my desk the past few weeks. And if you then don't clean up, yeah. You soldered 6mm to the connector last week. Wasn't fun. No clue what. Oh, 10 AWG is 5.5mm. So yeah. But we'll try and make it work. What I'm thinking is we'll pre-tin the connector, and we'll pre-tin the wire, and then we'll basically smash it together, right? I need some heat shrink. Hold on. Oh. Good luck and try to have fun. Yeah. Let's see here. What kind of heat shrink should we do? Maybe this heat shrink will be okay. That should be 3-to-1 heat shrink, so yeah, I think that's okay. Time for a smoke break. I need to check if this heat shrink will go small enough. I don't actually know. So we're gonna shrink it. There. Let's turn on this guy, and put on the glasses. There. Okay, and let's give this a shrink. So let's set it to 200. Should be plenty. Oh. Okay, heat shrink when it's not on a cable doesn't want to stay put. Set it to 1 billion. No, you'll just burn the heat shrink. There. But the question is, now of course I can't touch it. Yep. Is that small enough for the cable and this connector here? Although mostly for the cable. I guess the connector... But yeah, the cable looks about the same size. So it should at least adhere to the cable and somewhat to the connector, so that's fine. That's okay. Well, we can use that. Oh, that's hot. Okay. So let's get 2 pieces of heat shrink. Did the music die? Oh, there it is. Okay. We got the heat shrink on there because I always forget. Although we probably would have been able to get it over the force. Okay, that works. I don't remember. There, like that. Yeah. Like so. Now we need to strip it again. You don't like XT60s or XT connectors? So let's strip it. Well, basically the same amount, I'd say. I thought about using Anderson's, but XT in general. Oh, okay. Oh, you've soldered an XLR and forgot the strain leaf. Ah, this is a bit dark, isn't it? There, that's better. Okay, I am going to twist it again, because I need to get it as small as possible. Yeah, Andersons are nice, but I didn't have any that would be the right size, even close. So let's see if I can use this guy, because I want to pre-tin these. So I think I should fill them with tin. There. Nope, the big side. So now I can fill this with tin. I can tin the leads and then press them together. I think that's the way we're going to do it. If anyone has a better way to do it, let me know now. I'm going to start anyway, but I'm going to use one of my new soldering tips. Okay. There. Okay, that should have some solder in there. Let's see. Yeah, there's some solder in there. Okay, that's good. Let's do the other side. Did I do the wrong side? No, I did the right side. Okay, this is angled down. There. Okay, so now we have two that are pre-tinned. Okay. Can I still separate these? Yes. Ow, ow, it's hot. I don't know what I was expecting. Okay, let's pre-tin these wires. This one's still nicely bundled. Okay. Tenet Max, he said? What? XT90 for that size AWG. Oh. Okay. Well, we're not going to do that. Come on. One little hair escaped. Oh, two little hairs escaped. Okay. So we're going to use my little mini vise again. And we're going to do plus first. There. No, it's okay. It's still fine. Well, you can't really see, but it's still fine. It's pretty big anyway, so... Oh, Jesus, how am I going to do that? It's bigger than the connector. I'm just going to try and jam it in there as much as I can. Of course, there's going to be a problem holding this. There, I think I'm going to do it like that, using a plier, and then just push it together. Oh. Let's have it join a little bit. Okay, let's see how that did. Rapid cooling is always good for it. Okay. I mean, it's not perfect. Ideally, the wire goes into there. But that's a fair joint, I'd say. Needs flux and more solder? Really? No, I'd say that's a pretty good bond. Okay. Let's see if I can pull them apart without this dislodging. It's probably fine. Yeah, I think it's fine. Yeah, that's pretty well joined. Okay, let's do the other side. Or should we heat shrink it first? Maybe if we heat shrink it first, nothing of the other solder can ever touch it, right? Let's do that. Maybe 10, but at max, generally 2 or 3. Sorry, trying to get this on the screen. Okay, let's turn it around. Yeah, but the problem isn't the amount of amps, the problem is the distance. I want to make a 1.5 to maybe 2 meters of cable, and then doing 2 amps, you kind of want a large diameter cable, right? Okay, so this is now also heat shrinked. That went pretty well, I'd say. And this is heat shrink with glue in there, so that's going nowhere. Yeah, that's true, Dave. I can always check for that. So let's do it like that. All right, I need to hold it with the... because I can never hold on to that. Sorry if it's out of focus. You guys said flux, right? Let's try some flux. So how am I going to do this? I need to hold this here. Then douse it with flux. There. And now hit it with the iron. I think that's okay. Well, it certainly looks in there. I think I'm going to add some solder to it real quick, but I'm afraid it's going to disconnect while I add the solder. No, it's at 380 degrees, it's fine. Well, that's what I was afraid of. Yeah, I have to redo this one because it... Oh, man. It kind of separated for a little bit. There. Okay, that's better. Yeah, that's much better. Okay. I'm glad I already heat shrink the other one. It's not perfect, but that should be fine. That's in there. Yeah. Okay, let's heat shrink that. If we can still get it over there. Yes, there we go. Nice. Okay. I need to do that over here. Sorry. There. Okay. If you'd look at that, you'd say, oh no, that's really close together. But there's two heat shrinks in between there, so that's going to be fine. Yep, pretty good. So the next thing we're going to do is we're going to... this is some leaded solder. So yeah. Oh, Kitty's here. Hi, Kitty. Yeah? Okay. So next we're going to take some super glue. And we're actually going to try and glue it in here, because that would make for the nicest way, basically. Because this just fits through here, but barely. Ow, ow, it's still really hot. Yeah, it's leaded. Yeah. Otherwise I'd need way more flux. No, Kitty went outside. Okay, so I can get the whole connector through there. But of course we only need the female side. Or the male side, I guess that's it. So like that. Oh wow, I hope with this cabling like this, it's still going to fit. I guess we'll need to bend it up and have it like so. Yeah, I guess that'll work. Yeah, lead-free, I mean, I'm a hobbyist, so all my prototyping I do with lead, and then I have it built professionally lead-free. I have lead-free, and I use it sometimes, but yeah. So I kind of wanted to have it sticking out like this, because the other part mates with it like so. So it goes into the other one. So it doesn't actually have to stick out that far, maybe like that. But I'm just going to use some super glue and see if that's going to hold. Let me get the glue, hold on. We have this dangerous stuff which says Achtung. And the more warning labels are on your glue, the better it is. I think that's the rule. Real hobbyists use hot glue. I have hot glue, but something tells me this stuff is going to hold better. Where did I put my glasses? Yeah. Okay. Well, sure, but I think this glue will be even better. So I'm just going to go for the jank approach and glue it on the inside and the outside. So let's try and put this over here so it doesn't move, like so. Oh, that's crooked. Make the connector flush. Yeah, I'm not really sure what you mean with that. I mean, there's not that much wall there, so if I only have it poke out that much, I don't know, it doesn't give me a lot of surface area to glue, I guess. Yeah, why not, Arnold? Because you sometimes order the wrong thing, and then that's what you're stuck with. So that's why not. So I'm first gonna do it on the outside here. A little bit like this, I guess. Okay, and then I guess I need to hold it for a little bit. On the bottom of the inside, I don't understand what that means. Well, it's a prototype, but I might use it for a while. I need to hold it in place. I don't know how long. Oh, it's not moving anymore. No, it's already not moving. So let me check this side and add a little bit here. Okay, let's have that dry. I can show you a bit better now. I don't think I got any in the connector, so that's good. And next we'll basically do the same thing on the inside. Oh no, it's angled. Okay. Next thing we'll basically do the same thing on the inside, and then we'll leave it dry for a while. We're your activation spray. Nice. Now I just hold it for a while, I guess. Best live stream ever. What did you do this weekend? I watched Quindor watch glue dry for 10 minutes. It was awesome. Well, that's still a bit wiggly. I don't have all these things. I just have this little bottle of glue. I don't have baking soda or CA glue. I don't have SDH, whatever that is. Okay, so I think it's good. So now I'm going to do the same on the inside. Can't really reach the bottom, I think. Yeah, okay. This is the best it's gonna get. Okay. No, it's so tightly fit you can't really put anything on the side. That's okay. Okay, let's leave this dry for a little bit. How do I don't know how to put it somewhere so that it doesn't go crooked. Use concrete. Yes. Oh no, the glue is running all inside of the case. Can't show you that. Oh, I don't know how to put it. I guess I'll put it like this. There. Perfect. Okay. So now we get to do the second part. And that is outside of the case. So outside of the case, we need another XT60 connector. Well, we can leave it dry for a little bit. That's fine. I mean, we could do that with the heat gun, but right now it's got at least 10 minutes of time to dry. So I don't think we need to do that. So the next part is we take the other side of the XT60 connector, this side, and connect wires to that, which will then have to drill through our fake faceplate here, and then once it's through there, we can make it to the into the chassis and make it a hole again, right? So we'll first make this cable to the XT60, and I guess we'll use the same procedure as we just did, because I haven't seen any better procedure yet. So we'll use this guy. No, we'll first prepare the cable. How long should this cable be? That is the question. I'm just gonna get some cable. Where's my cable? Okay. 1 billion millimeters. That's a lot. I don't know, man. Okay, let's see. I guess this, I don't know, what's 1 meter? Something like that. Okay, let's say I want to have it here on my desk. You guys can't really see that. I want to have it here on my desk, and the cable needs to go over and under, over here, and then it might need to go over there. So let's make it this long. That's a decent length. I mean, it's a decent length, but not too long, I think. So I'm going to use the scissors this time, because last time sucked. Yes, much better. How was this? Just like that? Okay, so now we need a positive wire that's the same length. And voltage drop isn't that important because the end device is converting it anyway. So, but you also don't want it to get hot. But 10 gauge, I mean, it'll be fine. It'll be fine. Okay, so let's see if I already have enough. I do. Yeah, voltage drop becomes an issue if you're feeding something that needs 5 volt like an LED and expects 5 volt, but then because of voltage drop you only give it 4.5 volt, that will change its function basically. But if you have a buck converter there, which can take anywhere from 20 to 36 volts, and you're outputting 5 volts, it doesn't really matter if it's 20 volts or 24 volts or 30 volts or even 18 volts coming in, it can always make the output voltage. So you might get too big losses on that cable though, and it might get hot and things like that, but yeah. Okay. Yeah, this is fairly the same length. It's 10 gauge at 6 meters, 30 amps. Yeah, no, I'm way beyond. This is like 1.5 meter, 10 gauge at what are we? 69.5 volts and maybe a few amps. Yeah, so that should be fine. That should be fine. Okay, wire stripper. Okay, then heat shrink before I forget. And last time that heat shrink fit okay, so we can just gonna use the same one. Okay. Yes, I'm going to twist it again. Well, that'll be fine, I think, Felix. We're not going to drop a lot of amps, or a lot of volts, and yeah, basically it should be unnoticeable versus how it was originally. Okay, let's pre-tin these wires. Yeah, but I like being overkill, so I could have maybe gone with like 12 or even 16 gauge, but I don't mind this being a beefy cable. Oh. Okay. That looks fair. Oh. No, we'll fit the other side through there. This is going to be the XT60 side, and then the other side we have to fit through there first. Okay. So this is plus. Let's do that first. Some of it came undone. Okay, so let's feed plus, yes, feed solder in here first. Oh wait, Johnny said something about having the other side connected. So let's do that. Ow. Okay. Okay, so now we pre-tinned that. We need our little tool to hold it. We have the heat shrink. I'm gonna do it like this. People like flux. Oh wait. There it goes. That looks like a good connection. Yeah, that's soldered in there. Good. Let's do the heat shrink. Yeah, I need to do this off camera because my hot air station doesn't reach much further. Perfect. Very good. That's looking excellent. So that's all heat shrunk on there. So no chance that's going to be touching. So let's, oh, we already pre-tinned it. So we only need to solder it on there. Yeah, that's hot. Is anybody still watching? there. A nice bit of solder in there. Hey there, Sparky. With great interest. Nice. Okay, let's hold this in place again. Oh, we add flux, right? Let's see, somewhere over here. I'll add some flux on here too. And then we just squeeze it together. That looks perfect to me. Yeah, that's a very good bond, I think. That melted all the way in there. Good. Don't need this anymore. Ow, that's hot. Still hot. Okay, I need to heat shrink it real quick. Okay. Well, that should do fine. Actually, I'm now thinking it would have been nice to have a heat shrink over both of them together too. But, well, I guess I could still do that. No, I'll use some Velcro, actually. We're going to use all the tools. We're going to use heat shrink. We're going to use Velcro. All the stuffs. Because this was actually some misordered cable, or it was misdelivered, but I generally have 2-wire cable that is linked together. So flux for soldering makes the soldering a lot easier or even possible. It basically etches, it's a sort of acid that etches the metals to become receptive for the tin, basically. So without it, you're going to have a hard time getting it to bond. And the solder, it's hard to explain really, but it basically activates the both sides that they want to join together. Sorry, that's a bad explanation. That's the best one I've got right now. You could see it as a sort of activator. So what I'm going to do right now, I'm going to use some of these Velcros to make this a 2-wire cable anyway. Because, as I said, I usually like 2-wire cabling better, but this got misordered somehow. So, yeah. By the way. Yeah, you basically need flux to solder to have a good bond and have it joined together. Most solder wire has flux in it, but as Felix already said, if you have spikes or tails or things like that, especially with leadless solder, flux helps a lot. So this is just me being cheap and not ordering new wire. I actually already have, but this wire is perfectly fine. I just, you know, I hate that it's apart, so I'm joining it together. Yeah, so flux helps with it joining it together and also going the place where it should go. So it also prevents bridges and things like that. Okay, last one. So let's see, we have this cable here now. Let's try and stretch this out. Okay, that length should be fine, I think. So now comes the next part. We don't need the fuel sucker anymore. There. We don't need the solder anymore. Okay, this can go, this can go. Let me clean up a little bit. There. Okay. So next part is let's first see if we take this guy, and it's probably going to be a hard fit. But let's see if we can take this guy, our fake front plate, and fit it into here. Okay, I think that mostly fits fine. I can push it in a little bit. But the problem is these clips, they are fake 3D printed clips. So there's no actual springiness in them because I didn't remove the infill that's right here, basically. All right. So I think we're just gonna go for it and then ram it in there, and then once it's in there, it's never coming out. It's gonna break and it's gonna cry, and you know, that's okay. Okay, so we have this power supply here. Let's disconnect these leads. So we've got negative over here. Okay, these are already forks, that's good. Now let's see what kind of fork we can use. Because we need a 5.5 dash something. I'm hoping the dash 5 will just fit. I think so. It's a bit of a tight fit, but it would fit. Actually, that's fine. Yeah, that's fine. That's fine. Dash 5 fits fine. Good. Let's find the other side. Nope. Yep. Oh, that one's bent. So let's see, this goes to here, but I'm gonna use the middle one. I don't know why, but it feels like it's then best spread out or something. There. So in theory, this should fit. This should fit fine, right? Yeah, this fits okay. And over here. Yeah, and especially if they're pushed all the way in, they make a great contact here with the screw and the metal below it. So that's good. That's fine. Okay, we can use those. So then we have the front plate. And let's put it in the right side up. The funniest thing would be if they went in here. Or actually these two. Because on the actual unit, ground is over here and red is over here. So what we could try and do is drill that out. Yeah, we could try and drill that out. So that, oh, okay, we don't need this anymore. So that these actually fit in here. That would be coolest, right? That would be really cool. And in theory they could, it's just not hollow enough or something. Is it hollow all the way to the bottom? Yeah, it is. Okay. So it's hollow this deep. Yeah, okay. So it's hollow all the way to the bottom. So then I just need to find a drill bit. Oh, this is going to be such a mess. I'm going to be cleaning my desk for weeks again. Okay. So, no, yeah. Okay, let me check the other side. So these are masonry bits, I think. Don't think that's the right call. These are Forstner, so yeah, Makita kit. Yeah, I have everything from Makita. When I was building the house, it was like, okay, let's do it right. So these are probably also not the right ones. So let me turn it around. And we have more over here. I'm thinking one of these. But then, what diameter? So let's say we get a 2.5, whatever that means. Does it fit in here? No. Okay, so in theory that's good. Let's go one size smaller. One size smaller, hold on. Maybe one size even smaller. Yeah, because these almost fit. You need the black drills? Really? I mean these? Or these? Okay. So this is a 5.5. So let's try this one. This is a 5. Let's see if that... Okay, so a 5 almost fits. Maybe we should start with that. So we drill this 5 in here. And then see if it fits. And then we probably have to step up to 5.5. Because that's also the cable diameter. Oh, I guess we should do 5.5, huh? No, we don't need a pilot hole. None of that crap. So let's see here. Now that might fit. Instead of drill, melt it in. Yeah, but how? I think I'm going to use this bit. I don't need a pilot hole. Where did this come from? Okay, whatever. Heat the drill. You want me to heat blast the drill? What do you mean? Okay, let's set it to 1 and drilling mode. Okay. Now we need a protective surface for my desk. The drill will heat itself, yes. No, I know 5.5 is without the plastic sheathing, but we're going to try it anyway. And if it's not big enough, we're going to enlarge the hole. Now, I'm sorry I can't really show you this any better. Let's put on the safety glasses. Don't run too fast on plastic. Yeah, high speed. No, low speed. Okay, I'm just gonna go for it. Oh well, it's working. Am I there yet? No, I'm not there yet. There we go. Okay. It's probably still too small, but at least I didn't break the pillar, right? So let's see. This was red. Yeah, okay. As we expected, this is still too small, because this is the wire diameter, but then without the outer sheathing. Okay, so we need to step up one drill size, and then we might be there. So we're going from a 5.5 to a 6. See, you did make a pilot hole, sure. Okay, so I guess I should drill this one at a 5.5 too, and then enlarge it with the other one, just to make sure stuff doesn't break. Okay, that went pretty good. Okay, it's a little bit warm. So now we already have 2 holes, but now we're gonna enlarge them. Okay, let's hope I don't break this pillar completely, but it's a bit big. Okay, there we are. Wow, okay, it still looks pretty good. But let's see if it fits. I mean, we don't know yet. Oh, so close. Oh yeah, it works. Oh, hold on. Oh, there's crap in there. Yeah, I only used like 8% infill, so probably infill crap. Ah, there we go. Ha ha ha. Let me try and get this off. Where's my little tool? There. Don't need that. Perfect. Okay, let's do the other one. Like factory. Exactly, like 3D printed factory. Okay, let's do this one. Okay, let's, I don't know, clean it up a little bit. So, can we now insert the red one and the black one? Yep, here's the black one, and there's the red one. Okay, so we need to have enough. Okay, drill can go. Let's see over here how much we need. Because if we... Oh, okay, we don't need that much. We put this in here. How much do we need? Something like... Well, we got a lot of space here. It's okay to use that. I have a little bit of slack. Something like that. And then we should easily be able to plug those in here. So let's crimp them. Okay. I'm going to hit this one another time. There. Yeah, that's fine. Yeah, I don't really mind if it moves in and out of the case a little bit. But that's a good suggestion. Well, I wasn't going to make any, because this is the strain relief already, right? No. I don't think it needs much strain relief, really, because it's going to be screwed inside. And that's pretty sturdy, so... Yeah, I don't think there's going to be any strain relief.
Alright. I'll tell you the truth.
There. So let's pretend this is in here. Can I then make a nice connection like so? For ground. Yeah, that's okay. Right? I think that's fine. Okay, let's just screw it down. There. Yeah, that's going nowhere. Wait, is it moving? No, that's not. That's not moving. Okay, good. And now this needs to go in. You know what I'm going to do? I'm actually going to use a hammer. But to do that, I'm first going to go and assemble the case so that the case becomes a bit more sturdy. And then we're going to hammer it in. I'm not going to repeat that, but I agree. So I'm first going to put these screws back, because that also provides rigidity to the case. Now I need to see if I get screw holes here. I don't. Why are there no screw holes here? That's odd. Did I do something? Oh, it's on backwards, probably. There. No, I mean, it's not going to work because there's infill there where there should be space. So it's not a matter of it not fitting, it's a matter of it not bending. So we're just going to mash it in there and see what happens. Come on. Yeah, but I'm afraid the tabs will break. Of course, they also will if I just hammer it in there, but then it's in there. Hot air in the tabs. Maybe. That's actually not a bad idea. Let's first see how it goes. Because I think it'll be okay. And if not, coaxing it in with some hot air might actually be a good plan. Hulk smash! Yes. Okay, so can I set it like this? Yes. So this needs to go like that. So let's see if trying to just... No, we need a hammer. Hold on. Actually, for such occasions, I bought one of these. So it's a kind of a rubber hammer. It's a Biolin special. It's okay. If it breaks when it's in there, that's fine. So this is a Biolin special. Oh, okay. So let's see. Eye protection, yes, sorry. Good one, Dave. Yeah, it's gonna need a bit of force. Doesn't really want to go. Oh, this one's in. Okay. 3 out of 4 sides. Okay, so this side is in. That's fine, that's not coming out. It's never coming out. And this side, it squished the tab. So the tab got stuck. Oh, the tab got kind of stuck here and disconnected. So let me see if I can get it. Or if I can push it in. Oh. I was afraid of going in too far and messing up the electronics. It's a 3D printed plastic port. Okay, there. And now we hammer it in again. Okay. So this side isn't perfect because the tab broke, but the bottom side is. I mean, I can't get it out. But this side's in pretty firmly. I'd say that's fine. You know, it will give up at some point. Exactly. So now we did it. We now have a power supply. Oh wait, we still have to do the other side. So let's see, we have this power supply here. And this should now be fully dried. Hope that I didn't get any glue in there. Oh no, it's not dried at all. How did it not dry? I need to get some tissue paper, hold on. I'm hoping it's oh wow. Huh? The whatever came off is yellow. Like the filament. Is it dissolving the filament? Heat gun? Okay. How many degrees heat gun? Like 150? Don't melt the PLA, exactly. It is in there, I mean, it's not moving. 70. I don't know if my heat gun goes to 70. Oh, okay. Oh, no. 100C. It's going to be 100C. That's the lowest I can do. Yeah, it feels solid. Okay. On the inside. Okay, I think there's some fumes that came off of that because my eyes are starting to hurt. Let's open the window real quick and open the door. Hold up. Are you guys secretly trying to kill me? What's going on? Okay, that should be enough. Okay, now let's try and wipe off the excess, because I really put a lot of on there, so it's maybe just the excess that's dry. It's funny that it's yellow though. It's only yellow, it's not black. Or the XT60, yeah. No, I also tried wiping it from the top, and that's not going, so... But, I mean, if I wiggle the connector, the whole housing is flexing, so I think it's actually fine. I'm just going to leave it like it is. So, does this say in... Okay, this says... in negative and in positive. So if we line that up, like, wait, did I do it wrong? I did it wrong. There. This is indeed in negative, in positive. Because if we connect this side, it's... Oh wait, there's already a connector on there. It's also like that. There. Okay, yeah, that's good. Okay. So, let's bend this in the correct way. Well, we didn't need to hammer it last time. It just kind of slid in there. Problem is, this is now sticking out. Okay, there we go. Okay, well, that went in there just fine. Well, I actually tried to buy the proper connector, but I horribly failed at that. So, you know, it is what it is. That's why we're doing all this now. There, that's in. Damn it. Okay. And now we have this little box. So this goes on the desk with this cable connected, which can only go in one way, which is the right way. There. And then we have all this cable here. I was going to say in hindsight it's shorter than it looks, but I could now put it on this wall over here and that would still work. So anywhere on my desk, or at least in most places I'd want it, it should be good. Okay. So I guess we need some AC. Let's turn this off. Don't press the keyboard. Yeah, double-sided sticky tape or some brackets or both. Okay. So let's turn on the power. I think the power supply... Oh, no, I was going to say the power supply is still off, but it's not. It's booting. And we're getting 69.59 volts. 5.8, 5.7. That's exactly the same as we had before. Okay, so now this is all running through this cable, right? Cool. Okay, good, nice. So actually, what I ended up doing is making it bigger. This isn't saving me space. This is now extra space. Kind of sucks that the back is pretty big though. Maybe should have made that at an angle somehow. I don't know. Well, there's maybe angled XT60 connectors. Maybe. Who knows? Or maybe let's. Okay, I was gonna hot plug it. Don't hot plug it. Maybe you can actually buy an adapter, a 90-degree adapter for XT60. Do those exist? So I can just plug the adapter in there and then the cable goes this way, because now it's taking up a lot of space. I'll have to look that up if that exists. So just an adapter that goes that way and I can plug it in like that. Sure, you can use wire straps. There's these venting holes, so you could you know, attach the Velcro to here, but I don't want to create a bad bend here, right? It would have been nicer if it would have gone out and then that way. But I don't know if that kind of connector or adapter exists. Yeah. Oh wow, it's a little bit warped here. I'm not sure why. Is this pushing in? Oh wow, okay, what's going on here? Ah, okay, the screw connection that's over here basically doesn't give this any room to bend, so it's actually bending outward the plastic a little bit. So I really can't move this. Yeah, I have so many wire straps. I have too many wire straps. If you watch Quinbox, you know. Okay. Well, I'd call this a success. This works great. Okay, so to round this stream off, I'm gonna take this. I'm gonna put this back in its original place for now. Or somewhat at least. This looks so stupid. This is like the biggest troll. Well, hold on. Let me... Damn, okay. Right angle adapter would have been nice. Anyway, hold on. Let me get this camera. How much troll is this? So it has the stupid the same faceplate. And then it's like total fake. I like that. That's good. So let me put these drills back. It looks so stupid. It looks so stupid that it's perfect. Okay, let's get this out of the way. Let's get these plastic scraps off my desk real quick. And then it's time for the secret, and we're going to power the secret using our new contraption here. Now it's not a lot of amps, but still. Yeah, but the whole thing is, this thing is going to go under my desk. I'm never ever going to see it again. Or at least that's the idea. So speaking of my desk, here's my desk again. And we have a special candidate today. And that is this guy. Now remember when I said, do you see those fuses? Look at that. There's lots of those fuses over here. Interesting. And what's this? A PowerBoard 5 HV? I thought we only had a Power 7 HC. Well, now we have something else. And this is prototype, but this is a PowerBoard 5 high voltage. So this will support... does it say anywhere? It does say somewhere, but it's below the... it's actually below the brain board. Oh, okay. Well, you can see it here, I guess. This one supports 24 volt to 48 volt. So let's try and wire that up. I need to wire up my power supply first. Oh, I can already tell I need to put some rubber feet under it. Because now it weighs nothing. Okay. Let's get these screwed in. Hold on. I'm just preparing the leads here. Okay. There. Okay. I guess I'll show you guys. Oh, no, go away. Okay. I guess my cable can be shorter now. What did I press? Shift? No. I don't know what I did to my display. Okay, that's fine. So this is for all those 48 volt and 36 volt addressable LEDs that have started to become available. And before I didn't have a native option of running it. There were some ways with diff advanced and the data booster and things like that. But this will be the first method of how you can use your normal brain board. So the brain board didn't change. It's just a new now I can also put it in screen on the screen. Anyway, it's a normal brain board, but it's a different power board you can buy. It's a bit more complex than the other power boards because it has to do some power conversions and things like that. But if you then have some... Let me disconnect this. Need to reconnect this. No, this will be a separate board because it's not 5 volt compatible and I still have to test other voltages. But this is specifically meant for high voltage applications. So it will do less good in low voltage applications basically. Oh, okay, this one came unconnected, that's fine. So I already was testing with this, of course. So this one goes here. This one goes here. Yep. Yeah, so this one will be a 24 volt to 48 volt basically. And lower than that, I'd recommend using the normal power board. So the normal power boards can do 5 to 24 volts. So they basically share 24 volts. But if you want to go higher than that, you need the HV version. So we have a brain board on top of there with a single data connection going to these native 48 volt LEDs. Well, they're not native. Each of them have a buck converter inside. We took them apart on some live stream. And we have a power connection here. Now this power board has PTC protected inputs so that they also do power sharing over the terminals. And that is 3 times 10 amps. So it can do 30 amps in total. Now if you calculate that with 48 watt, that's a lot. 48 volt. And then it has separate output terminals. You're allowed to use a 10 amp fuse on them. I think I'm going to deliver them with a 5 amp fuse. And even that is, well, that's a lot of power. How much power is that, Mr. Calculator? My cables keep pressing keys. So 5 amps times 48, that's 240 watts. And the board can do, that can't be right. 1440 watts. So you can actually get a 1500 watt power supply if you're running a lot of these 48 volt pixels, right? And you can use a brain board with Ethernet. Oh, we need the Ethernet. And everything included in the normal brain board because it's a normal brain board. The brain board didn't change. You can use the brain board you have right now. You can even add this board to your stack. If you already have a normal power board, you can add this power board in the same stack and it'll all automatically work. Okay, so let's set it to 5 amps and 48 volts. I don't know how I did the display like that. It's kind of annoying. I'm going to turn it off. Let's see if it comes back. Yes, good. That's what I wanted. So we have 69.48 volts coming in. We want 48 volts out with 5 amps max. Let's go. Well, okay. Should I put my glasses on? Yes, I should. Is anything going to explode? Probably not, especially if I have my glasses on. But here we go. Beep. Okay, there we go. Let's see, I need to go to this IP. And now we can make them red, or blue, or green, or have them do a little effect. Let's lower the lights a little bit. There we go. And, well, it doesn't look very spectacular, but up until now, if you wanted to run 48 volts with WLED, you had to do all kinds of manual stuff. This will just be something you can buy, and it will be fully protected on the input and on the output sides, and it has a capacitor per output and central bulk capacitors, so a lot of power smoothing, reverse polarity protection, and all kinds of stuff built in. So the brain board can only take up to 24 volt. So there's actually a buck converter on here, which takes the 48 volt in and makes it about 15 volts, which it then sends through Q power post to the brain board so that it's compatible with the normal stacks and well, the current brain boards, etc. So there's power conversion happening on the brain board where on the power board where the current power boards don't need that because, well, the brain board can do 5 to 24 volts. And of course, as you said, the fuses need to be rated for 48 volts. These are 125 volt rated fuses. Your capacitors need to be rated for at least 48 volts. These are 80 volt capacitors. Your diodes need to be rated for at least 48 volts, and all the components basically need a spec bump because they need to support that higher voltage. And well, they do, because you can even hot plug it. And this one, I believe, is broken. Yes. So even my broken fuse indicator lights, because this fuse is broken because I blew it, they also work. So this next output should also be broken. Yep, also works. And then the next one should just work, and you'll probably see a little arc. Yep, bam. You heard it. You heard it. So it needs to be able to survive such a spike. Both the LEDs, but those seem to be doing that well. But also the power board without the ESP rebooting and things like that. So there's all kinds of tolerances and clearances and things you need to take into account for a high voltage design. But so far this prototype seems to be working quite well. Yeah, we're not drawing a lot of amps. Let me try and connect more. There. So now I have no, oh no. They all came undone. Come on. Trying to get these all on the screen. These aren't working for some reason. I don't know why. Did I break these? I don't think so. Oh, these are off too. Maybe my configuration is just wrong? Let me check. I think so. Huh. Did I break them? How did I break them? Sorry, now I need to investigate. Where does it stop working? Ah, here, it stops working because it's not connected. Okay, now we're up to 22 points. Oh, you can now see the wattage on screen. There is only advantages. Okay, let's go back to 100. Oh, 100 LEDs, and then we'll crank it up. Save. Yes, good. Okay, let's go to solid, and let's do no color, and only the dedicated white channel at 100%. Okay, so that gives us 30 watts or 0.6 amps. Okay, now let's add RGB white. Okay, so now we're doing 70 watts at 1.47 amps. And our input voltage dropped by 0.05 volts. I think we're okay. I think it's working. Later, old school Gabber. Hear that noise? That is that stupid fan in the power supply. And it's not this box. It is the power supply. Anyway, let's turn this off. Let's make it do a little effect. Yeah, so anyway, hopefully near you soon, we will have a Power 5 HV. So it will only be a Power 5, because it doesn't really make sense to do a Power 7. We already have the Power 7 HC, so that's geared towards lots of current. But because the voltage is so much higher, we're not going to have a lot of current, so I thought the Power 5 was more suitable for that. And it has 12 outputs with pluggable connectors, which are also more suited for lower amps. So, yeah, I think that makes for a very nice design. So yeah, that's an upcoming thing. It's not done yet. I still need to do some more testing. But so far, testing has been great. And so far, our little remote extension box here also does great. So I'm going to leave the glue to dry for a little bit, although this hasn't moved at all. So this seems... Come on. Come on. That seems pretty sturdy. It's fine. I am going to look for an angle adapter that could make the cable angle like that. But other than that, I think this is a great success and working perfectly fine. I mean, I've been moving it around and it hasn't failed, so that's generally an indication the connection is good. And even if we use like an amp and a half at 48 volts, no problem. So yeah, that's going to be it for today. I hope you enjoyed one of these project live streams again. It's one of the things I wanted to do for a while. I was like, okay, let's do it with you guys here. Hit the like button if you actually enjoy that. If not, that's fine too. But I hope to see you back on a next live stream, in the Discord server, in the YouTube comments, or, well, maybe in the next live stream or video. Thanks for watching, guys. Bye-bye.